All right, so we're going to finish up number 6. We had decided that this absolute value is not needed. So we're going to go ahead and take the antiderivative of the velocity function, which is going to be the position function. So it'll be 6t squared divided by 2 minus t cubed divided by 3, evaluated at 3 and 0. So just cleaning it up a little bit, 3t squared minus t cubed over 3. Again, evaluated at 3 and 0. We're going to put 3 where t is. So it's going to be 3 times 3 squared minus 3 cubed over 3. Okay, 3 times 3 squared, that's 3 times 9 is 27. Minus 3 cubed over 3, so that's 27 over 3 is 9. It's going to be 18. And if I put a 0 in there, it's just going to be 0. So I'm not going to worry about that. The correct answer is going to be 18 for number 6. All right, so let's take a look here. 18 for number 6. That's D for that one. All right, so we're going to go down here to number 7. And we're just looking for y prime. So it looks like just a derivative. As long as we know our chain rule here, we're okay. If we ever have a function inside a function, like we do here, something whose derivative is not 1 inside of some other function, then it's going to be the chain rule. So we'll rehearse that here. So let's look at our board. All right. So the derivative of the inside, that's x to the third, is going to be 3x squared. And the derivative of cosine is negative sign, but since we have a negative already, it'll be positive sign. Okay, that's the derivative of the inside function. Okay, then it's that times the derivative of something to the 5th power. Well, the derivative of something to the 5th power is 5 times that something to the 4th power. Okay, so minus cosine x to the 4th. And one of the tricky things in calculus is when are we fully simplified? A lot of times it just depends on the tolerance of your instructor or the test you're taking. So this being a multiple choice test, we can look back and see if we can figure it out. Yes, it's going to be E here. Okay. And if you look back at the camera, the 5, it's in a different order. What they have is the 5, then this, and then 3x squared plus sine x. So show you again. So it's going to be E for this one. Number 8. All right, so you have a tank contains 50 liters of oil at time t equals 4. Okay, it's being pumped in. Okay, a little table. Looks like it's going to be a Riemann sum. Yeah, so it says using a right Riemann sum with 3 sub-intervals and data from the table. What's the approximation of the number of liters at time t equals 15? Okay. Well, for a Riemann sum, got an eraser here somewhere, can't find it. For a Riemann sum, we use either the left-hand side, the right-hand side, the midpoint, or you can use trapezoids. Here they want the right-hand side, I believe it said. Yeah, so I'm going to copy this table and just explain a little bit about what this is, or just review it a little bit. Of course, if you're watching this video, you should about be ready to take the AP exam and just need a review. Okay, so certainly this doesn't substitute for a full lesson on it. But for a right Riemann sum, what we're doing, as you can see, these are basically y-based. They're decreasing as x increases. So it's a decreasing function, the part that we can see. So when x, which is t here, is 4, t-axis, we're at basically at height 6.5. Okay, so we're here. But when we get over here to 7, the height is only 6.2. All right, so it's a little bit lower. And we have a function that's coming down like this. Well, for a right Riemann sum, we use the right-hand side of the rectangle as our height. So we're actually taking this rectangle right here as the area for this part between 4 and 7. Now it's going to leave a little gap here. Sorry, I didn't realize it was so low. So again, with 4 to 7, 6.2, 6.5. And what I was saying is we use the right-hand side. We could use the left-hand side. If we use the left-hand side, you'd have this rectangle here, which would overcount this space. But we're using the right-hand side as the height. So we just go straight across, and it makes an undercount right here. And we're going to continue to do that for all these rectangles. You have rectangles of different sizes that continually use the right-hand side. Okay, so we're going to have this undercount since it's a decreasing function. So this would be rectangle number 1 right here. And if you remember, the area of a rectangle is length times width. So the width of this rectangle is 7 minus 4 from your x coordinates. Okay, so my area is 3 times, and we're using the right-hand side as our height. So we're using the right-hand side, not 6.5, but 6.2, the one on the right. Okay, similarly, this will be rectangle 2 here, where the width is 5, and the height, remember, we're using the right-hand side, or the side with the larger x. So times 5.9. And finally, we have this third rectangle. I said to use 3 subintervals. 15 minus 12 is 3, and then we'll use the 5.6. Now, this would not be the case. You'd have the same, the 3, the 5, and the 3 would be the same regardless, but the height would be different based on if you're doing a left, right, midpoint, or trapezoid is a little different. Now, this is intended that you do it without a calculator, so we should be able to do this. 3 times 6.2, well, 3 times 6 is 18, so 3 times 6.2 is 18.6. 5 times 5.9, well, 5 times 6 is 30, so take away 0.5 will be 29.5, and 3 times 5.6, let's see, 3 is 15, and 1.8, so 16.8. Okay, and then if we add 18 and 29, that's 47, plus 16 would be 63. Then we have 6, 5, 1.9 extra. Okay, so I'm calculating that correctly. That's 64.9. Let's read the question. And don't be too impulsive here. 64.9 is A, but remember, we want to know between, we need to know at 15 hours. That includes the first 4 hours, which we didn't calculate. Okay, between 0 and 4 hours, we already had 50 liters boil in there. You have to account for that. What we calculated was from 4 to 15. All right, so we have to take what we calculated and add that original 50 to it. All right, so be careful. That's going to be 114.9, which hopefully is an answer on here. Yeah, so C for that one.